Hello friends, welcome back to our API review. Today we're going to focus first on Writable Dom and dynamic support in JSON for .NET 6. And then this probably takes an hour and then we will do the remaining issues. I think I have the doc open already. Yep. Steve, do you want to walk us through it because you wrote it, right?
You're not sharing.
I'm not sharing my screen again. Okay, let me fix that first.
Just a couple, some history, I guess, on it before we open up the shared doc. Originally, we wanted to support dynamic in 4.0, and it missed schedule, so we punted it, and we got a lot of feedback from the community along the lines of, we really need this, and I'm blocked because of not having support for dynamic. So I did create a quick plugin model that you could use all the way back to 3.0 that does support dynamic in a rough way. And after that, then I created this document that is an attempt to formalize the requirements and then add it to 6.0. However, in kind of in the meantime, this is described a little bit in the doc. There was some overlap with prior work, including a prototype that we had in the 4.0 timeframe around Writable Dom. And then also my prototype, and then some other thinking around dynamic and Writable Dom as well. But in general, this doc then combined two things. It combined the dynamic stuff and the proposed Writable Dom. The previous support or proposal that we had for Writable Dom in the 4.0 timeframe, which was in prototype stage and went in our repo for a little bit and then was pulled out, did not have support for dynamic. So if we added dynamic after that, we would have had yet another way to get a Writable Dom. So this proposal attempted to bring those requirements together into one design. And this is not the API doc. This is more of a discussion doc, design doc. So I'm still assuming there'll be another API doc after this meeting.
Yeah, that makes sense. So I guess this is more than the document that's kind of capturing what it is that we want to achieve then for .NET 6.
Mm-hmm. Are you sharing yet?
I thought I did I not? It says it's...
I mean, Team switched to a mode that suggests he's sharing, but it's not sharing anything.
Okay, then let me just share my entire screen. Maybe that works better.
I can paste a link here too.
So now it says I'm sharing screen, so you should see the doc and the comments.
I see it.
All right.
Okay, we have.
Does it work for everyone, or is it just Corey can see it now?
It just popped up for me.
All right. Then take it away.
Okay, yeah, so the overview mentions kind of what I went over. We had a prototype in 5.0. Disappeared. So that first bullet says, yeah, the Writable Dom prototype, and I did mention that. Dynamic support code example. This is the example I added for those that said they were blocked. And it basically uses a custom converter to override the behavior for system.object. It works pretty good, I think. Then the Azure team also has a prototype and I think a package you can download and use that has yet another version of Writable Dom. It's more tuned for performance, and we have been working with them, and they do want to take the whole dynamic model, C# dynamic support, and system link expressions DLL. They want to take that and move it forward. So they're actually working on that. And I'm trying to stay in the loop on that, but that's kind of disconnected from this effort right now, other than we're asking that team to review this here in a 6.0 time frame. It was kind of understood that any kind of new dynamic support probably won't be there in time for 6.0, since it spans C# and Roslyn releases. So so these three things are all influencing this doc. But again, this was originally created for support for dynamic, which is a loosely typed model. You know, it looks like it's strongly typed, of course, but it's not. And based upon some feedback in this design, if you go and click the link that Levi shared, that you will see that James Newton King and others have said that we need a more loosely typed model than what I originally had. So this has been updated to minimize the number of casts you need. So it's a lot less strongly typed than the Writable Dom prototype that we had in 5.0. So it's just kind of that mentality, I think, is something that we need to discuss, because when looking at the APIs, they're focused around more of the dynamic scenarios and not a rigid DOM model that we have for JSON for the existing DOM support that we have, which is read-only today with JSON document and JSON element. It's a very rigid model. Very nice if you know exactly what your scheme is. Not so nice if you just want to write minimal code. Okay, so yeah, if you want to scroll down and talk about this dynamic section a little bit. Okay, this is just discussing some plumbing to get the dynamic support working. If you're not familiar with the dynamic, I try to describe that a little bit here. There are implementations to support dynamic, including dynamic object and expando object. We looked at using both of those, or either one of those, for 6.0, but I list some reasons why we don't want those. And this is also true for the effort going on by the Azure team, that they couldn't use these classes primarily for performance, but also because they tend to clutter up the API. They have a lot of unnecessary methods or interface-based methods that you have to that will show up in the IntelliSense. So the low-level way to implement dynamic is to support iDynamic meta object provider, and that's what this prototype does and what this document assumes right now. It also assumes that because of linker support, that we don't have to have a reference to system link expressions DLL, where this interface lives and really all of the plumbing for dynamic lives. So originally in this prototype, I had a way that I had two assemblies, or an extra assembly that I added to support this dynamic support. However, talking to those that work on the linker, it was decided that that wasn't necessary, and that the assembly reference we have to system link expressions would go away if you're not using this feature. That's assuming a certain programming model to enable dynamic, which we'll get to later. Basically, the system link expressions deal is very large, and scenarios such as Blazor client, they don't want to bring along this if they're not using the dynamic feature. Okay, I can scroll down here a little bit. I talk about the system link expressions assembly, and there are two aspects to this here that are two different ways to think about this. Is that we have an API, it works without dynamic, and then we have the same API that works with dynamic more under the hood, if that makes sense. So even though we have a writable DOM that uses dynamic, when you want to use dynamic, you can still use writable DOM without dynamic. So dynamic support is enabled at runtime if you want it. If you don't want it, you still get the benefits of the writable DOM. It just it doesn't have the dynamic features. That makes sense. So that's what this enable dynamic types method is for. It's assumed to be called. I'm not sure why this is static right here.
So I'm not entirely sure I understand. So the idea is that the user has to call this method somewhere in the code, and when that's the case, then we know we can't link away system link expressions. Is that the way to do it?
Right. Yeah. And I don't know why these are marked static. This class's methods. I think that's just a typo. But
I see. And then it doesn't really matter when it doesn't matter how the method is called. It's just anywhere in the code. It doesn't mean that that's under an if statement.
Well, it does have to be called before you use the options class, just like today. You can't change the options once you serialize or deserialize. It needs to be called. It should be called before that. Otherwise, you're going to get, I think, some odd behavior.
Yeah, so I guess what I'm asking is, does this thing do anything, or is it just a marker for the linker?
It's mostly marker for the linker. Yeah. I mean, what it does do one thing. It adds a custom converter to the options class.
I see. So if you don't call this, like it won't work no matter whether the linker removed it or not.
The support for let me think about this for a second. The support for system object, I have to look at what I wrote. It's been a couple months here since I think I updated this, but I believe the current thinking is that this will add a custom converter for system.object that enables dynamic support. And it can't contain an if statement. It has to work with the linker. That's why there's no like a bool property or anything like that. Instead, it's just a method like this. Because if you try to make it a bool, the linker won't understand the if condition.
Another option here is to use what we call feature switches, which is like more or less like at your build time or at your publish time, you can set an option to say either turn on or turn off this feature, whatever it is by default. Like if this is only for linkability, there's other options than public API, is basically what I'm saying.
Yeah, I guess it also depends whether you want opt out or opt in, right? So if you, like, I think if it's an opt in, which the API kind of implies, then your linker switch might be odd because, if you're not using, even if you don't use the linker, right? If you don't call the method, dynamic types just wouldn't work at all, right? And so if you want to make people, if you don't want to pay the penalty for it by default, then an API makes sense. If we basically want a behavior where dynamic types just work, unless you say for the linking, I really don't want this, then I think a linker option would make more sense.
Yeah, I mean, if it's adding a custom converter, then Steve, my recollection is this type is self-closing. Like once you do serialize the first time, it starts throwing if you modify it. So this does, under your current thinking, have to be called before the first call to deserialize. Otherwise, you'll get the options are closed for changes exception, and it wouldn't do anything.
Yeah, and I did verify the existing code. It does add a custom converter for system object. So yeah, but yeah, Jeremy, you're right that it does have that behavior. I mean, you have to use it before you serialize or deserialize, mainly because it's adding a custom converter, and you can't add one after the fact, after you start serializing, because we have internal caches and things that would need to be cleaned up or refreshed.
Can you check that at a later time? It seems like you might run into weird dependencies, making sure it's called before whoever needs it first.
Well, the proposal here is wrong. It's not static. It's instance on an options instance class.
Oh, so you would call this for every instance of the serializer options you wanted to use dynamic on?
It's very similar to all the other options that we have on this class. If you want to set a property naming policy or ignore null or anything like that, you just have to do it at the same time you initialize this type.
Okay.
Yeah, so far it seems reasonable.
Okay, so if you want to scroll down to the next page. So yeah, sample code. Yeah, it's not a static method, so sorry. Just call the instance method, and here's an example of using the dynamic keyword with JSON node. And if you're not familiar with the dynamic keyword here, C# uses it and understands it, but really it's looking at this interface, it's using this interface that I mentioned earlier to address my prop here. My prop is, of course, not a property on JSON node, but it is present in the JSON. That makes sense.
What happens if you don't call enable dynamic types? Like in this code sample, if you comment out that part.
You'll get an exception because the type being returned doesn't implement that interface.
On what line? On the call to deserialize?
Yes. Or after deserialize returns in the C# attempts to use that interface, you'll get an error.
Oh, so on the next line when I try to get...
I think it's on the equals.
On the line that has dynamic, you will get the exception. It's just a matter of, on the assignment, I guess. The deserialize will say, fine, I can deserialize JSON node, but then C# is going to try to cast it to this interface. And if it doesn't implement that interface, C# will throw an exception. But this is interesting because if you replace dynamic with JSON node, it will work fine because you're deserializing JSON node. So that's the case of not using dynamic, and then you wouldn't need the first 2 lines of code either. But this is just saying this is how you deal with dynamic at the highest level. The JSON node T parameter for deserialize, in theory, that could be object, or it could be even the dynamic keyword, and I talk about that in the next thing that says varying the T and deserialize T. It's just a matter of syntax. I think having JSON node here is one way to do it. You could say object or dynamic. Probably object makes the most sense over dynamic. If you use dynamic as the T parameter, it's equivalent to object. But anyway, this is just different syntax for the same thing.
So what happens? So can I actually say JSON serializer.deserialize of dynamic?
Yep, and that's the same as using object. At runtime, that dynamic changes into object for generics.
Right.
So there's a difference between the two there.
So, but like we handle this, right? So if you say of object, we would still give you something that would support dynamic and basically is an instance of JSON node, I guess, right?
If you say that again for the which option?
So basically, if I say JSON serializer.deserialize of object or deserialize of dynamic, I guess that is logically equivalent with saying JSON node. So basically, what we give you back is an instance of JSON node that then, by extension, supports dynamic so long you enabled it, right?
Yes, exactly. Yep. If you enabled dynamic types.
So what happens today if I say JSON serializer.deserialize of object? Like, it's presumably that also works. It just doesn't do anything meaningful.
No, it does, because we have a custom converter today for object that returns JSON element. So this, without the call to enable dynamic types, what you'll get back is JSON element. If you specify object.
I see. So that means I see. So it's a bit more than just enabling dynamism. You're also basically saying, well, now I want a different behavior for deserialization of object, because otherwise it would be a breaking change to give you back something that would be JSON element JSON node rather than JSON element. Interesting.
Okay, you can scroll up, I think, to the next section. There's just more samples here. Supporting non-dynamic to dynamic. By the way, we did have a tiny review 3 months ago, and with Jeremy Leomi, just to kind of go over some scenarios that's changed since then. But one of the asks back then was, if you created a non-dynamic JSON node and want dynamic support, it would be nice to be able to do that. So this is just a little piece of trivia. Maybe it's coming too early in the doc here to talk about this, but there is a proposal to add a dynamic method. But let's just skip over that for now, if you don't mind.
Makes sense.
The reason why I want to skip over it is because there's a static class JSON extensions, which I did not clean up in this last commit. I should have removed that and just added it somewhere else.
So presumably JSON node is your representation for the mutable DOM, right?
It's the base class for the writable DOM types. It's abstract class.
And then dynamic JSON node and dynamic JSON object are basically just derived types that add the dynamic support to it, right?
Right. And yeah, eventually we'll get to the API section that kind of talks about that. But yep, that's the JSON node is the base class, and then there's JSON value, JSON object, and JSON collection that derive from that.
I guess my question was more like there is no inherent penalty for using the DOM towards dynamic, right? So like I can use the DOM without paying for dynamic in the same way that I can use the serializer without paying for it.
Okay, let me see. This section talks about some scenarios for the writable DOM. One of the interesting things that we ran into with the serializer is like impedance mismatch between the JSON and the object model, the CLR object model. So you can have, for example, in JSON, a number, a JSON number, and normally that would relate to a double or an int or whatever on the CLR side. However, there's a feature that said, hey, we want to be able to use strings in JSON as numbers, quoted numbers, we've been calling them. So that means a JSON string is not always a string on the CLR type. I mean, it might be a number. That's always been kind of true for other things like enum values and stuff like that. You know, a string can be represented. I mean, a string can be used to represent an enum, and it can also now be used to represent a number. So it just adds a different way to think about the object model here, because a JSON number may not be, it may be a string in JSON or it may be a JSON number. So this design talks about that, shows examples of being able to convert between different representations of a number.
So that's interesting because I would naively assume that the DOM is a representation of the JSON encoding, right? And so then, to me, the fact that the serializer supports quoted numbers is more like a policy on top of the DOM, if you will. So I would have naively assumed if you have, you know, a property, you know, key colon, you know, some quoted string that happens to be 1.2 that, you know, if you parse it as the DOM, you basically get back a JSON string for that. And then, well, if you want to have support for quoted numbers, then whoever interprets the DOM would have to do the heavy lifting to convert them. But you're basically saying when I use the serializer and I enable quoted numbers, I would actually get back an instance of JSON number, not of JSON string?
Yes. I mean, JSON number represents a number, and you can obtain that through a string or through, you know, a primitive number type. I think scroll up a little bit so we get the whole examples. Okay, so here, yeah, we have JSON number class. It's saying deserialize a number as a string, and then it's asking for the double value. Another interesting thing with numbers in particular is that the JSON for something like a floating point number or 1.2. I mean, JSON doesn't have any concept of a floating point versus standard number. I mean, it allows decimal points, that sort of thing, but it doesn't know if it's a double or a float or a decimal. So JSON number allows you to ask for it. And JSON element, you know, the existing JSON element allows you to do the same thing. We just know it's a number, and you have to know what it is because it could overflow, it could underflow, and that's why we don't assign median and JSON element. Unlike Newtonsoft, I think, which will try to use a double by default. When you deserialize a number, there's no default primitive type for that. And this is just going over some examples of that. And NaN, not a number, is a string. And this is another case that we had to add support for in the JSON serializer is here we have a number. NaN, positive infinity, negative infinity, or two other values. But it's a string. JSON allows a string. It doesn't care. It doesn't even know it's a number, right? It's a string to JSON, but we treat it as a number because that's what floating point support. So it's really ties in, I think, some of the other requirements that we already have, and that are not possible today with like JSON element. Probably wouldn't, I don't think, work very well with this. Jeremy can correct me if I'm wrong, but I think you can convert a string to a number, but I'm not sure.
From the read-only DOM, I don't remember.
Yeah.
So one question I have is, like, your sample code is always using the serializer. Do you think that the primary way you actually construct the DOM is by calling deserialize rather than calling something like, I don't know, JSON object.parse or something?
Well, I mean, you could, but this is assuming JSON, right?
Right. Like, I mean, I'm just saying when I have a DOM representation, I wouldn't think of using the deserializer to construct it.
Right. Yeah. The examples here are purposely very trivial. Like, this 1.2 is valid JSON, but it can also be, a literal value. You'd use something like a parse method. But yeah, it's just for example only. I mean, imagine that being part of a larger JSON document.
Yeah, I don't know. Like, I'm kind of torn because basically, if you want to, on the one hand side, I can understand why you want the behavior that you say quoted numbers are parsed differently based on serialization options. But like, if you think of the DOM as something that you parse independently, it seems a bit weird to me that we have behavior where the parse tree differs based on, serialization configuration. Effectively, that seems odd. Like, because to me, I mean, maybe I'm just, old-fashioned, but like, if you think of like, lexing and then parsing and then, serializer, like, I would think that, lexing and parsing is independent of rules like, oh, we support quoted strings, right? I would think that's a later thing on top rather than, resulting in a different DOM kind of thing. And so because now the question becomes, if I have something like JSON element like JSON object or JSON node.parse, then in order for you to support this behavior, you now have to effectively design what are the options that can parse to the parse method. And that seems now, well, either duplicate effectively the JSON serializer options, or you have to support them. But then it's kind of weird because there's a lot of things on the JSON options that have nothing to do with a DOM, right? So it just, do you know what I mean? Like, it seems like it's just the wrong layer to do this kind of work, kind of.
So I think I understand what you're saying. I would say, kind of backing up here to my original statement about being more loosely typed. I mean, you can imagine that we don't even have this JSON number type. We just have JSON value, for example. But yeah, let's keep going. I get that.
Yeah.
But the purpose of this is it's kind of like, what comes first, dynamic or maybe a more strongly typed programming model? This design, because it was originally created to support dynamic,
Right,
assumes loose typing and casts when you need them, and it assumes that you know what the types are. Just like when you use dynamic, for example, a certain property is an integer. If it's not an integer, normally when you use dynamic, I mean, you can implement dynamic in many different ways, but normally the consumer of it knows what the given type is in the JSON. And it's not something that you inspect at runtime. You just hard code it, and that's the problem with dynamic in a way, because you can write beautiful code, and it compiles fine. At runtime, you can certainly get cast exceptions and missing property type stuff, and that's just the nature of dynamic and
yeah, I guess that's my mental model. Like, I would have assumed that what you get in the DOM is a truthful representation of the encoding of the JSON document. So if somebody uses a string, it's a JSON string. If something uses a number, it's a JSON number. But then, because of dynamic, I would personally expect that I can I can cast a JSON string to a number or a Boolean, and then that might succeed or fail depending on what the value ended up being, right? But I would think if I actually inspect the object at runtime, I would expect to find a JSON string if there were quotes, and I would expect to see a JSON number if there weren't any quotes, right? Independent of any options.
And I will say the design, I'm not even sure what the state it is right now. I honestly have to scroll down a little bit. But there was some discussion about not even having JSON number, JSON string, and those types. And like I said, just have a JSON value type, and don't disambiguate, I guess, with the type, and just have a single value. We still have to differentiate, I think, between collections and values.
Right.
But as far as numbers versus strings.
What did JSON.NET do? I think they have different types for the thing that can appear, right? They have, I think, JSON number and JSON string and JSON Boolean, right?
Yes, yep, they do. They do have a common base class similar to this, though.
I mean, personally, I think in a DOM, that's what I would probably expect to see. Like, rather than switching over a kind, I would assume I can just do, you know, casts. I mean, in a tree representation, that just feels more natural. But I don't have super strong opinions. I mean, yeah, I can see when you actually support the casting, you end up basically with JSON number, JSON string, JSON Boolean, effectively implementing the same thing because, well, they all have to be converted to anybody, right? And then that might be weird, but. Do you want to go with the API then, or?
Yeah. Show JSON node here, and I can go over that. Can you scroll down quick just to make sure we can see all the types here? So here's JSON node, and then JSON array, JSON object, JSON value. Okay, so scroll back up. Okay, so this was edited the last time I got feedback, and the example above that with JSON number, that's not valid. Sorry, I have to update this to replace the new API. So this current proposal says there's just a JSON value, and we'll get to that later. Mm-hmm. I think primarily because of the same items that we were just talking about, is that it is kind of confusing to have these, you know, string types versus bool types when they can be represented in JSON, or not a JSON number, that when they can be represented in JSON as different values. So the base class JSON node, it does have reference to the options class, which is maybe not something expected. However, the reason it's there is because it does support custom converters. Unlike the JSON element, JSON document stuff, which doesn't know anything about the serializer, JSON node is intended to understand the serializer. So that means it's up to the individual converters, you know, including custom converters that you might register with the options class, to support what you get or what values you get back when you call get value.
So could value is value always primitives, or can it be something like customer?
It doesn't matter what I mean. Okay, there's JSON object down below, and I guess we'll get to that later. But JSON node is intended to represent everything right now. I mean, you know, JSON array, JSON object, or JSON value. But JSON object is a built-in type, and if you have a custom converter for that, it's treated as a value.
No, I meant like the value property directly on JSON node, because you're saying it supports the serializer. So like, does that mean if I access the value property off of JSON node, do I only ever get back like a primitive, like, you know, an array of something, or you know, an int or a bool or a string, or do I actually get back some high-level deserialized object like customer?
You'll get back the high-level object. I mean, yeah, yes. Scroll down a little bit. I think I have some examples later about this. Okay, so yeah, I think JSON array and JSON object both have indexers. That are, scroll up a little bit, sorry. Where are the indexers? Oh, okay, yeah. There's two indexers here, one for JSON node. I mean, one for a string and one for an integer, and those are assumed to work with either JSON object and JSON array. This was added in the last pass based upon feedback to minimize casting. But the intent is that most of the time you just work with JSON node, and you call get value of t when you want to get a specific type, and in that case, you don't even really need to know. You don't necessarily care if it's an array or object. You do care, but the syntax doesn't make that clear. And again, this might be kind of too high level. This may be best to show examples, and I do have some examples later on this. Okay, yeah, JSON array and JSON object. Represent a JSON array or a JSON object. Implement iList and iDictionary, similar to Newtonsoft. JSON value used to be JSON string, JSON boolean, and JSON number. Now it's sealed. So that is there's a little cleanup, like I said, that has to happen in this doc.
So basically, JSON array and JSON object, the value add of using those directly is because they're effectively hiding the indexers from the base, right? So the first one basically gives me an in-based indexer that directly returns object rather than JSON node, correct? And then the second one, logically the same. It gives me an indexer that takes a string, gives me back an object rather than JSON node, right?
Mm-hmm. Yeah, the array is indexed by an integer. An object is indexed by a string, which is a property name. This makes more sense when you have a complicated syntax where you're trying to access something like 5 levels down, and you have to say, for element 2, I need, return that. Okay, this property as a string, I need that. Okay, now there's another collection off of that property. For example, you have, 3 levels down or something, mixed between an object and a collection. And it allows you to do that on one line without the intermediate casts.
Yeah, I think a thing that's not being shown here, like JSON node didn't have the iList members, and so there's actually a lot more members on this type than it's showing. Unless they're supposed to be explicitly implemented. But if you have a JSON array, you should be able to add some. It'll have an add of object and a contains and other things that the node level doesn't have. So if you're building one, you would want to build the array, so you can call add, and then now you let it go away. If you're reading one, I think the intention is you don't care, so then you just use the indexer off the base class. Did I get that right?
Yep, that sounds right.
So I guess my question is, if once I cast to JSON array, it seems like when I'm now indexing into a JSON array, I get back object. So how do I get back something that I can actually walk?
Well, you do get JSON node back. Indexes return JSON node, and then you call get value at the end of it.
Well, aren't they hidden effectively? Like I would have to upcast JSON array to JSON node to get back the indexer that gives me a JSON node, right?
No, JSON node itself has the indexers on them to return JSON node again.
Well, yeah.
So does JSON array explicitly implement the indexer that returns object for iList of object? So it's only returning JSON node things?
Yes. Yep, and I could look at the code here. I can share some of it if you want, but the current prototype is functional in this. It's functional in the sense that it implements the API here, and you can take a look at it, I guess, after this side here, and see what object and list do.
So when is the iList of object implementation visible then? I presume people would not explicitly cast a JSON array to an iList of object, right? Is that just for the dynamic infrastructure, or is that something that people are actually expected to be able to leverage?
The indexers directly?
Yeah, or anything that comes from the iList implementation, right? Because if everything is explicitly implemented, then the only way I would get to them is by casting my JSON array directly to ilist of object, which seems unlikely.
Yeah, this does not show all of the methods that are implemented. I mean, it just shows ilist. If you look at the code, some of them are implemented explicitly to hide them, and some of them aren't.
I see.
But you would have to cast a JSON array, in order to call those, or cast a ilist or whatever. But some are implemented explicitly and some implicitly. When we actually do the API review, they'll have to be called out. But
Right.
for example, a lot of the iDictionary methods are not very commonly used, and we would want to hide some of those just for confusion's sake. But in general, you use the indexers to go down to a certain level, and then you can either cast it to JSON array if you want, or you can call get value or try get value on the JSON node to get the value out during the read mode. And I should have examples later. If not, the actual private branch has a whole set of tests around this that you can look at.
And so your DOM is also mutable, right? So the value is settable. So what happens when I set it to something outrageous? Like, let's say I'm standing on a JSON number and I assign a string. Like, I guess that works when coded numbers are on, right? But if I set it to something like, Imo is the best person in the world, then presumably that throws an exception, right?
Well, I got rid of it, just a value.
It doesn't matter until it comes time to serialize it, I believe. I'll have to look at that scenario later.
Interesting.
To see when the actual error, if you do get an error, when does that happen? In the case of node, it's just a value. It'll get serialized no matter what it is if you set it. That's kind of, I think, one of the reasons why it was just changed to a node or a common type, and not and not on each individual derived class. There are questions, for example, like on the get value, if you don't match up the T with the current internal value, what you get back. And I do talk about that later, and it says or convert to T as necessary. For example, if you internally, we're probably going to use JSON element because that already works today very well to return abstraction on top of a JSON value. So we used existing support we already have, and then when you call get value of T,